We did collecting, organizing, the summarizing. With the summarizing, we did measures of center, measures of variation, measures of position. The last section here of summarizing is when you have two different variables and you're comparing them. So it's called linear correlation and regression. Starts pretty easy and then, well, it gets hard with the calculator, but some of the topics can be tricky. So starts easy by recognizing the x and y intercepts. This, most of y'all know, a lot of you probably tested out of this, but the x-intercept you have the x-axis, which is a horizontal one. The y-axis is your vertical one. We don't have to do a lot with y equal mx plus b, but we got to do a little bit, and we'll see how well you all remember that in just a second. But your x-intercepts is where it crosses the x-axis, so that my x-intercept is 4, and then my y-intercept where it crosses the y-axis, so that is -2, okay? So most of y'all have seen that before, so I won't spend too much time there. We want to talk more about, I've told you all this a million times, I feel like now, not how to do some of this math, but like how to interpret some of it. So that's what we're going to look at. Another prerequisite topic is the classifying the different graphs. So when we look at graphs like this, we don't actually have to do the horizontal and no, we won't have to do that, but I'll write it over here anyways, just because. The ones we'll have to deal with are the positive and negative, so we always look at these from left to right. So this one is going up from left to right, so it is positive. This one is going down from left to right, so it is negative. Those are the key ones that we'll look at. The other two is if you ever have, I was trying to decide how much I wanted to go into it. So like it's y equals mx plus b, but when you have y equals a number, it creates a horizontal line. You don't have to know this. This is just extra. And on those, my slope is always 0. So my slope is 0 on this horizontal line. If it's x equals a number, it is a vertical line. And my slope is undefined. Okay. So we don't deal with those too often in this class, but it never hurts to refresh over some of that. But we will talk a lot about the positive and negative part of it. All right, this is another one that's kind of prerequisite, but kind of not. This is number of hours worked compared to amount of spent on entertainment. So you have two different variables. You got your x's is the number of hours worked, and your y's is amount spent. Usually x comes first, y comes second if it doesn't specify. I guess it tells us on the graph that the number of hours worked is down there by the x-axis, and then the amount of spent on entertainment in dollars is the y-axis. So you go to x5 and then y6 for the first one, and then you go to x8, y9. Most of y'all, like I said, probably can do this pretty quick. X9, y11, x10, y8. Did I get off already? Looks like I did. That one should be 9, 11. 10, 8, 11, 10, 13, 13, and 14, 12. All right, so what we're going to look at is how these graphs, how these graphs and the shape of them and which way they go. Okay, so, oh my goodness, I did it twice. So we're going to see how well these variables correlate. So like we are going to look at the line that goes through these and say, okay, these have a positive association because they're going up from left to right. And that's where we're getting to. But these are just points that they give you. So let me write these real quick. And of course, x is first, y is second. Okay. All right, so starts. What's the next topic? Linear relationship and sample correlation coefficient. All right, well, let me talk about this for a second before I get into this. Okay, so the sample correlation coefficient, they use the letter R. to denote what the sample correlation coefficient is. So when they have R like this, that is what we're looking for. R is either going to be positive or negative. Okay, it's always going to be positive or negative, so it's going to tell us how strong, I guess that's what it does, tells us how strong the correlation it is, how strong of a correlation it is, okay? The weird thing about R is it can be negative or positive, okay? So what that means is R is always between, I hate writing it like this. Some people write it like this, the absolute value, which that's a little too mathy for statistics. I guess technically it can equal -1 and 1. But R is always between 0 and 1 or 0 and -1. So I always say it that way because R is either positive or it's negative. So as R is 0 and as it goes towards 1, it gets stronger here, okay? So you would call this a strong positive correlation. And then if it was down here close to 0, like 0.02 or 0.2, it'd be a weak. They will also use the word like moderate, but these are all the positive ones. And then the negative ones is as it goes towards -1, it gets stronger. And then as it goes towards 0, it gets weaker, okay? And same thing, if it was in the middle, you could say moderate. So the weird thing about this is if you have like 0.85 and -0.92, this one is actually stronger even though it's negative because it's closer to -1 than this one is to 1, okay? So you kind of look at the positive and the negative separate as you look towards the number. So you always, this one's stronger because it is closer to -1. Oh, no. Because it's closer to -1 than this one is to 1, if that makes sense. So that number denotes how strong of a correlation you have between the variables. And then we'll probably, I think the next topic is going through some of those different ones and what they look like. Oh man, I can't see my questions at the same time. Let's see if I turn it this way. Can you all still read it if it's like this? All you really need to do is see the pictures. All right, so they give us 4 different graphs here. If you can tell the direction of what it's going, it is going to have a positive or negative. Like this one right here, I can't tell. That has no, we would say this has like no correlation because, or it would be very, very close to 0. I can't tell if it's going up or down, right? But if you think about like drawing a line, like these follow a path going down, right? So this would have a negative correlation. It wouldn't be super strong because it's not really close. This one right here would be, they call this a perfect negative correlation because this is in a straight line, so it is like R equals -1, okay? This right here has a positive. This would be like a strong positive. I'm hesitating writing what word I should use here because I would say moderate, but they, since we can easily tell that it's negative, they may say like moderately strong or something like that. So our questions, which data set is the sample correlation R equal to -1? That's going to be these right here, the UV ones. So you would actually pick data set UV. Let me change the colors of these real quick. All right, which set has an apparent negative but not perfect? Okay, so that would be the one that I just highlighted there. It would be this XY one because you can tell it's negative, but it's obviously not perfect. It's not in a straight line. For which data set is the sample correlation coefficient R closest to 0? That is going to be this one right here. This one, R is going to be close to 0 because there is no clear positive or negative trek there. So what is that? MN. Which data set indicates the strongest negative linear relationship between its 2 variables? I'm glad I got this one because that would be this one up here. It would be UV. You can use the same one twice. You don't have to use all of them. Okay, so the questions will do that to you. That one would have the strongest negative. All right, so if you think about that line, which we'll talk about the line in just a minute, but if you think about that line that goes through the middle of those, that kind of tells you how strong it is, how close it is to a straight line. Which one was I on? This one. Okay. So you can make two things correlate. Just because you can make data correlate does not mean it actually happens. Okay. So like I can actually say that as ice cream sales go up, crime rate also goes up. Okay. So they have a strong positive correlation. Can you think about why, as ice cream sales are going up, crime rates go up? Anybody got an idea of just brainstorming through that one?
You said ice cream?
Ice cream sales and crime rate. I can say those have a strong correlation.
People are like robbing gas stations for ice cream.
People want ice cream. No, I mean, that's possible, I guess, if you had really good ice cream, but no. What, you got one?
It could be like a undercover like drug thing.
So
it's like I'm making ice cream, but like meanwhile like
yeah.
something like
Y'all are
that.
getting very specific. Y'all watch too much Law and Order or something.
I mean, I've heard of like a study before where the cops used. Yeah, there was like something about before they had air conditioning, they had like people would always get ice cream when it was super hot, and then the
Okay.
criminals would break in and stuff like that. So.
You're on the right track there. The problem is asking a bunch of Floridians this question. As ice cream sales go up, ice cream sales are highest when it's in the summer, right? So as temperature goes up, ice cream sales go up, and also as temperatures start to go up, crime rates go up, okay? So they call that a confounding variable because that you can actually kind of link it like that. But that doesn't really mean the more ice cream you eat, the more likely you are to commit a crime. So what we do here is we can use the data to come up with correlations, but we got to use a little common sense to say that actually could cause it. And actually statisticians never back themselves in a corner. They're going to say things like, it may or may not cause it. That may or may not be the cause. Yeah, like that's hard for Floridians to answer that question because, in a cold weather city, like people don't commit as much crime when there's 4 feet of snow outside. Like it's a little harder to do. So that's why that happens. They put some new ones up. They haven't updated the site in a long time. So last time I got on it, they didn't. So you can take this website. You saw me just Google weird correlations. But this one, you can actually take all sorts of data and compare it, all sorts of different data sets. So how much yogurt you eat corresponds with the Google search for I can't even. And if you look down here, it does have the R value. The R value is 0.939. So a 0.94 correlation. That has a very strong positive correlation. So if you eat a lot of ice cream, a lot of yogurt, you're more likely to search I can't even. They definitely updated these. Popularity of the distracted boyfriend meme. This one has a 0.97 correlation with the number of office clerks in Kentucky. Okay, this website is just to show you that you can correlate really random stuff, but you gotta think, could it actually cause it? I was trying to see. So here's a negative correlation. They didn't put a negative in there, but it should be negative. It looks negative. Where's that one website? Or that one? They added. Come on. Sorry, they changed the website since I've been on it. Okay, so you can take the UFO and crime and compare it to any of the other data sets. Man, they changed the website. There was a drop down menu and it was, can I do this? Okay. Well, this kind of shows me. So here's there's a perfect correlation between the popularity of the first name Stevie and Netflix stock price. Just random stuff here. Viewership of The Big Bang Theory and Google searches of how to make a baby. If I go to the end, probably should have read some of these before I started talking about in class. That's fine though. There's a negative 0.99. Bachelor's degree awarded in law enforcement and the average length of casually explained YouTube videos. There's almost a perfect negative correlation. So yeah, you can take the point of this, and that's kind of silly, but you can take any sets of data and get a correlation, but you got to use a little common sense to see if they cause it. All right. So on this one, a yoga instructor collected student data who found that students who had less sleep did not tend to have a greater range of motion. So if it did not tend to, like, if there is no correlation there, so it says they did not have a greater range of motion, this one would be did not tend to have a greater range of motion. So there is no correlation here, okay? A traffic study determined that a large city population indicates a longer commute for drivers. Okay, that makes sense, right? A larger city population, if you have more people in a city, it's going to take longer to get to work, right? Traffic, okay? So we would say there is a correlation, but you always pick this one that said there may or may not be a causation. We don't know for sure if that's the reason that it's causing a longer commute time, okay? So you have to do further studies to actually determine if it actually causes it, if you could prove it multiple times and things like that. So you always do pick that one. I picked the two that had no correlation. Company found that employees who start work earlier do not necessarily drink more or less coffee, so they're not seeing in correlation, so that's no correlation. I don't know if I need to do another one of these, but just make sure that you always pick that there may or may not be a causation. Just because they show a correlation in one study does not mean that it actually can cause it. All right, so that has to do with the letter R and the sample correlation coefficient. To get into the least squares regression line, this topic always messes with people, but this is what I was talking about on that one where you're looking at the R. When you think about these, you are just looking at a line that goes through these, okay? All I'm doing here is showing that this line is about the average of these points. So it has a positive association. All you have to do is randomly draw a line in there. I'll check it. As long as you're close, it'll count it right. Okay, so you just have to draw a line in there. You don't have to do anything. When you click at the explanation, it actually shows the equation, but it's in parentheses. That's just if you actually did the math behind it, that's what it would be. But all you have to do is just make sure the line's about in the middle, and it will give you points for it, okay? Don't make that one harder than it is. That always tricks a few people up, and I'm like, no, this one's actually super easy. I'm going to write that right here for anybody that goes and looks at this. Just draw a line in the middle. Best guess. Are we going back to correlation for a second? Scatter plots and correlation. I don't need that anymore. I didn't open. All right, so this is interpreting the correlation. So you can look at it and tell the line. It has a line there for you, so it has a positive association. For these 24 movies, as theater revenue increases, rental revenue tends to increase as well. The rule is, and I'll kind of draw this out in just a second, but if it's positive, as the X is increasing, your Y is going to increase, and that creates the positive trek. For negative, it's actually as positive increases, the negative is decreasing. Okay. For these 24 movies, there is a positive correlation. Using the line of best fit, we would predict that a movie generating a revenue of $40 million would generate a rental revenue of approximately. So if I go to 40 right here on my graph, I know y'all can't see my pencil, but I'll get my answer first. So if I go to 40 and I look where my line is, it's about 8 or just over 8. So we'll do that 8.4. I'll get my pencil and you can see what I'm talking about here. Okay, first of all, if it's positive, it is always increase. Okay, as your X's increase, your Y is also increasing, and that makes the positive line, okay? If it's negative, it is decrease. So as X increases, Y is decreasing, and that creates the negative shape. All right, so that creates a positive. The 40 million right here, the 40 million, what I would do with that is I'd come from this X equals 40, look right here, it's just above 8. What do you keep doing? Oh, you don't want that either. Okay. So that's just at 8.4. So we can use that line, that linear regression line, to actually predict what would happen once we get the equation. Let's just go to, I was going to use that example, but what was the name of it? Interpreting the slope line. All right, y'all got to use your algebra brain for just a second here. Again, this is one that if you look at it, it has send data to calculator, it has send data to Excel. If you look at the explanation, it's going to have a bunch of stuff. Just do this. Okay. It has, if you look at the explanation, it has some crazy formulas. So it may even like show you, if you click on some of this stuff, some crazy formulas. You do not have to do any of that, okay? All you have to look at here is the y equals mx plus b. So let's talk about the y equals mx plus b. We are looking at the GAS score, the generalized anxiety score. Whoops. Go away. Back to question. That's my issue. Oh. What is happening? My goodness. Y'all have your, is the Wi-Fi working fine in here? Yeah? Maybe I just wasn't connected on my phone. Come on. All right. On this one, so we are comparing the GAS score to sleep time. They use this Y, they call that Y hat. That is a prediction. So we do not have this actual data. They're just using Y hat for that. A lot of times in statistics, they write it like B plus MX, okay? It actually makes more sense when you're interpreting it to write it as B plus MX instead of MX plus B. They may even use like B sub 0 plus B sub 1 of X, but that is the same thing. So, what are we starting with here? Let's just start with our y-intercept. So our y-intercept. Does anybody remember algebraically how you find the y-intercept? You can look at it and do that, yes. But if I was just trying to find the y-intercept, do you remember how to do that? If it wasn't in like y equals mx plus b? What did you say? You could look at the graph, but if we don't have the graph and it's not in y equals mx plus b?
Like x2 minus x1 and then y2 minus y1.
That's the slope formula. So hold on to that just a second. You're getting good algebra points here, but we don't have to talk too much algebra in this class. Yes. So the way you find the y-intercept algebraically is you make x be 0. Now, the only reason I say that, I tell you we don't do too much algebra, but that's 0 is like our starting point, okay? So this is always the way to remember what the y-intercept interpreted as. That's our starting point. So if x was 0, so if we got a GAS score of 0, how much sleep would we get, okay? So that's always our starting point. That's the way to think about this. Now, you said the slope formula, y sub 2 minus y sub 1. This is our slope. What's the two little words that go along with that formula, or slope? They start with the same letter. Rise over run, okay? So what you are going to do, and this is the way you interpret these things, you are going to say how much it is increasing or decreasing, okay? All right, so let's look at this one right here. So I would say, if I look up at this formula, the way I would interpret this formula is I would say, if I had a GAS score of 0, I'd sleep about 8.4 hours a night, okay? But for every time my gas score goes up 1, I'm decreasing my sleep by 0.27. Okay? That's how you interpret this. So let's read our questions. For these data, sleep times that are less than the mean of the sleep tend to be paired with gas scores that are what? All right. Now, the way they show this is they break it down into 4 quadrants. You can think about it like this if you want to. I'll show you another trick in just a second. But they're saying that if our sleep times are less than the mean, so if our sleep times are down here, okay, if our sleep times, I guess our sleep times would be down here. My sleep times are low. Do my gas scores tend to be high or low? They tend to be higher on this end, right? So this would be, they tend to be greater than, okay? This goes back to, remember if I said it's positive, it's increase, right? These pair up. So if it's positive, it's going to be the same. Like if it says less than, this answer will be less than. If it's negative, it's increase, so they will be opposite. Okay? So if my sleep scores are less than and it's a negative, then I know this one's going to be greater than. Okay? If this was a positive graph, those would be the same. All right, according to the regression equation, for an increase of 1 in gas score, there is a corresponding decrease of how much sleep time. This is our slope. My answer is going to be 0.27. I do not have to write the negative because it says decrease. Decrease insinuates that it's already negative. So it's decreasing by 0.27, which is negative 0.27. What's next? Interpreting the equation. I thought that's what I just did. No. All right. Same thing on this one. If you look at the explanation, it may tell you a bunch of formulas and stuff. Again, in this class, you're never going to have to do something crazy with formulas. We've already went through what the y equals mx plus b means. So let's just look at our questions. What was observed yelling price when the mileage was 24.6? Okay, so observed is the actual data that we got. Okay, the actual data that we got. So this one says observed. So at 24.6, I'm going to go find the 24.6. Is there a 24.6? Why am I not seeing it? Right there. It is 30.7. So we actually observed a mileage of 24.6 and the used selling price was 30.7. All right. Now, from the regression equation, what is the predicted used selling price when it's 24.6? This is my prediction. Okay, this is what I would base. It's like the average of all those points. So I'm going to use that for my prediction, and I'm going to say y hat equals 41.66 minus 0.49 times 24.6. Can somebody do that for me since he has my phone? What did you say, 30.59? Why? Oh my goodness. $30.59. Okay, so our prediction was pretty close right there. Those numbers probably shouldn't be the same. But if I look right here, 30.59. I'm sorry, we plugged in 24.6, didn't we? 24.6 would be about right here. 30.59 would be about right here. So you can see that the observed is just a tiny bit higher than our prediction, which is fine. So our goal is to predict as close as we can. It's hard to predict perfectly, so we're good with that prediction. So when it says observed, you look at the table, you look at the actual data. When it says predict, you got to plug it in. I'm skipping that next one for a second. Let's go to the other one. Classifying linear and nonlinear relationship from a scatter plot. All right, on this one, it is saying if they have a relationship or not. So which data set appears to show a negative linear relationship? The one that is negative would be the fourth one, right? That's going down. Which data appears to show a positive linear relationship in two variables? That would be the first one. That one's going up. Which data set appears to show a nonlinear? You can do a quadratic. A quadratic equation makes a parabola. We don't go into that in this class, but you can at least mention it here. You can have shapes like that. Like you have your profits. Like the profits could be going down, and then all of a sudden they start to turn and go up. The set appears to have no relationship. In 3, I cannot tell any shape on that one. Why did it zoom out like that? Or zoom in, I guess. I'm getting struggling today. Okay, so this one has a positive. This one they would say have a quadratic. This one has none. This one has a negative. Yeah, we'll go ahead and do this other one first. We'll save that one for the end. All right. You can, to help your data come out, you can have multiple things you're comparing it to. So like what's this example here? Yeah, this is the one I want to do. Perfect. A real estate company studies the relationship between house prices and some important factors. Okay. Of some recent houses. So Y is going to be my sales price. X is going to be my total floor area, number of bedrooms, and the distance to the nearest high school. So like if you have a big house, or if you have a bunch of bedrooms, or if you live close to the high school, like that will all increase the price, or it may increase the price. Actually, we can look at this and say, so this one, like you have multiple variables that you're comparing. This is the only topic you got to do with multiple variables. But actually, I said that may increase. If I look at this one is positive. So if you have more area, that's going to increase your sales price. This one is positive. So that's also going to increase your sale price. This one is negative. So living close to the high school would actually decrease your selling price. Okay. So you look at them each individually, answer the questions of the interpretation of the coefficient of x cubed. So I'm looking at the x cubed one. Holding the other variables fixed, what is the average change in sales price for each additional mile from a house to the nearest high school? Okay, so this answer is -5 because that's the -5 in front of x cubed. That's the one we're looking at, right? But you have to be careful on this. You have to be careful on this because the sales price is in thousands of dollars. So my answer is actually negative, or the average change, so I just write 5,000. It's actually 5,000 because this is how much it's changing. Because it's asking for thousands of dollars. So make sure you pay attention to that. It does not do that every problem, okay? So you got to watch that. And is this change an increase or a decrease? It is a decrease because it's negative. All right, save the last one, the fun one for last here. I told you all this one. This is the one that you do not want to do by hand, okay? You never, ever do anything that's hard by hand in this class. There is technology that will do it for us. This is our first big topic where we use a bunch of the Alex calculators. So instead of making y'all go do sure, we'll do this one. Instead of making y'all go get samples of data and comparing them and come up with the linear correlation regression, they have this fancy little take a sample button. So it does a sample. Here we are sampling 9 houses to see if the distance from the water affects the selling price, okay? What kind of correlation do they have? So you have to fill out this chart. To fill out this chart, use the calculator. This is where it makes it easier. If you click on explanation, it's going to give you all the crazy formulas. What's wrong? Well, we're almost done, okay? Here. Okay. So we are sampling 9 houses. X bar. Okay, so it says the distance from the water is my X. So I'm going to send that to the calculator. Send the distance from the water to the calculator, and I'm going to hit X, the mean of X right here, okay? And that's going to find the mean of X. The average distance from the water of our data is 2.1, okay? I'm going to clear it so I don't get anything stuck in there. Now I'm going to do the same thing for the Y. So I send the selling price over there. I'm still going to use X bar even though it's Y because that's just finding the average. So my average, oh, see, did I click the wrong one? All right, so I send the Y's over there and find the average. Now I'm going to send the X's back over there, and I'm going to find the standard deviation. Okay, clear that. Now I'm going to send my Y's over there. I keep accidentally clicking the wrong one. Send my Y's over there and find the standard deviation. Oh, man, I knew I clicked the wrong one the first time. I did my Y's first on accident, so let's go check my X's again and make sure because we don't want to get this part wrong or we'll get the whole thing wrong. X's. Nope. My iPad is not liking me today. That's my X's. My standard deviation is right there.
Dad,
Hey.
be done.
Okay, go sit over there quietly. I'm almost done. You gotta go. What do you want, YouTube? Okay. 1.33229. Yeah, that's fine. Okay, so I sent the X's over there to get the X bar, sent the Y's over there to get the Y bar, sent the and use these two buttons right here, the X and the standard deviation of X to do the product. The sum of the products, I'm going to send the last row over there, which I can do that by clicking the bottom one. If it actually clicks, I don't know why. There, okay. And then you can use the sum button right here. So I click the sum button and press enter. 184.5. And this is going to find my correlation coefficient and my slope and y-intercept, okay? So my correlation coefficient is negative 8.9. That means as my distance from the water increases, my sale price of the house is going down, right? I mean, that makes sense. The further you move from the beach, the cheaper it gets, right? So my y-intercept would mean if I live 0 miles from the water, the average price is about 17.41. I'm guessing that is in like hundreds of thousands of dollars. So 17.41 times hundreds of thousands, 1, 2, 3, would be like 1.74 million. Like the average price if I'm 0 miles from the beach would be 1.74 million. For my slope, what that means is for every mile that I go away from the water, it's going to decrease the value by $268,000. Okay, this kind of makes sense in context, right? All right, so you write your equation in for part B. I'm going to write it as B plus MX because that's just the way we do it in stats, but it will count it right if you do it MX plus B. Let's get my X in there. Okay, so here's the hard part is making the graph. Or it's not hard, but y'all just got to like remember these steps right here. To find the graph, we actually have to draw the graph. To make a line, you have to come up with 2 points. The 2 points that you can use are the 0. Remember, X, to find my y-intercept, my X is 0. And my y-intercept was 17.1. So 0 in my y-intercept is one of the points you can use. Okay. The other point that you can use, I really hope it lets me do this. So that plotted okay. The other point you can use, it's super easy, is the X bar and Y bar. My X bar is 2.1. My Y bar is 11 point, I put a bunch of 7s in there, 7, 7, 8. So I plot those 2 points. So you use 0 in your y-intercept and then X bar and Y bar. And then I can come right here and I can say, okay, my first point was there. My second point was there. And if you did it right, your line is going to be in the middle of those points. Okay, so that's kind of how you tell if it's right. And then the last one, use the regression equation to predict the selling price that is 2.6 miles from the water, or kilometers. Oh, I was talking miles the whole time and it was kilometers. That's okay, still works. So 17.41 minus 2.68 times, what was our number? 2.6. Okay, we expect it to be, we just plug that in for our x. We'd expect it to be 10.442. All right, so if you're 2.6 kilometers from the water, you'd expect the price to be 10.422 hundred thousands of dollars. By the way, that is also an X and a Y that you can use. Every once in a great while, your y-intercept will be off of the graph. And you can use that X bar and Y bar. But the main thing that gives you all trouble, one, use the calculator for that first part, and two, the graph. So just to write these out real quick, to find points, use 0 in your y-intercept, or you use X bar, Y bar. You can use part C for one of your answers. That would also work. Okay, you do part C first and get one of your points. But on this part, make sure you use the Alex calculator. And then you do not have to do any of the calculations by hand. If you look at the explanation on this one, it's going to have the hard calculations by hand. Make sense? So this is the first one where we really stress using the calculator because you do not want to do that by hand. It is big. You know what? Just to make you, because I had to do this just the other day, just to make you appreciate technology. That is what the formulas look like to do by hand. They are not fun to do, okay? You see the R1, the R1's purple, and then A and B are the same. They kind of look crazy too. So appreciate technology that I don't make y'all do stuff by hand because that's not fun to do by hand.